Ever hit a bug and the thread that caused it is already gone? In this video, you'll learn a faster and easier way to debug Java code than what you're used to.
So no more time spent reproducing bugs. You can see exactly what happened across every thread and get to the root cause much faster.
Here's a bug that most Java developers will have run into at some point, a concurrent modification exception. In this case, we have our main thread iterating over an array list, whilst in the background another thread comes along and modifies the list, causing the concurrent modification exception. So let's run this in the usual way under IntelliJ. It failed as expected, so let's set a breakpoint where the exception was caught and debug it. We're now in the catch block, but the obvious question is, where is the thread that modified the list? There's no sign of the mutated thread, and this is a fundamental problem when debugging concurrent modification exception. By the time ArrayList detects the modification, the damage has already been done and the offending thread may well have fled the scene. Undo for Java solves exactly this problem.
Undo records the JVM's entire execution, every instruction, every thread, every variable change, into a single recording file. Replay it forward and backward to trace from failure to root cause in one debug cycle.
Okay, so let's enable the Undo for Java plugin inside IntelliJ. Now we'll create a run configuration to run and automatically record our application. Now we'll debug again using Undo for Java. Notice now that we have some extra debug buttons, reverse equivalents of the normal ones. These let us move backwards through execution. Now let's jump straight back to where the exception was thrown.
To do this, we set an exception breakpoint on the concurrent modification exception and resume backwards.
We're now at the throw site. Here we can see that mod count is not equal to expected mod count. And there is still no sign of the thread that last changed mod count. But now we can go even further back in time to see where mod count last changed by setting a field modification watch point on it and resuming back. And here we have caught mutated thread in the act of removing or adding an item from the list. This is the list mutation that invalidated the iterator.
Without Undo's time travel debugging capability, this thread is gone by the time you see the failure. With Undo, we can rewind execution and inspect it as if we'd caught it live. This bug was caused by a thread that no longer existed by the time we saw the failure. Traditional debugging can't help you there, because it can't go backwards. Undo lets you rewind execution to the exact moment state changed, even across threads.
Undo will save you days of engineering effort. Get your releases out on time, ship stable code at scale, resolve customer issues in one afternoon. You can try Undo for Java for yourself. Grab your free trial from undo.io.